Hello, everybody. Here we are with our final review of before Thanksgiving. Let's put it that way. Okay, so we have our naming review. We're going to start with the covalent compound side. We'll go through all this stuff real quick. Take about 10 minutes or so. What two types of elements are covalent compounds made up of? That is a very simple answer. That are non-metals. You put two non-metals together, you have a covalent compound. There are no ions involved. If we look at the properties of non-metals, covalent compounds, they do not conduct electricity. They have low boiling point and low melting point. Flammable, tend to be flammable. Soft, flexible, and they won't dissolve. They won't dissociate. That's the word. Won't dissolve. And I'll put the word dissociate in there also. Okay. So in covalent compounds, are electrons shared or transferred? Well, they are shared. That is a test question for tomorrow. In fact, all those three right there, 8, 9, and 10, are test questions tomorrow. 3 sentences explaining how covalent compounds are named. Well, one, I'm not going to put it in sentence form necessarily. You write the element name for the first part of the compound. The second one, write the element name plus you add IDE. And really, that's just 2 things that you need to know about that. Okay, adding IDE and then writing the element name for the first part of the compound. Now we're going to go fill this chart in. Prefixes. We have for 1, mono, 2, di, 3, tri, 4, tetra, 5, penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Okay? You'll need to know those. All right. So now we're going to name some covalent compounds here. We have the first one, SiO2, so we'll apply our rules. Si stands for silicon, so just write silicon. And then we've got a 2 right here, which means di. And we have oxygen, which is going to be oxide. Remember, it's always the first element's name for the first part, even if there's a prefix that has to go with it, like now. We have oxygen and fluorine, but we have a 2's for both of them. So it's going to be dioxygen. We still write the entire element name, and we have difluoride, IDE. Okay? Xe, Xe is xenon, and we write the name, and the 6 means hexa, and of course the F is fluoride, F-L-U-R-I-D-E. That's very, very important, IDE. Then, phosphorus pentafluoride. So for phosphorus, we're just going to write the P. Penta means 5, and fluoride will be fluorine, so let's put our F there. Penta being 5, we're going to put a 5 right there. Always at the end. Boron, put a B. Bromide is bromine, so put Br. And then tri, put a 3 right there. 3 means tri. Tri means 3. Diphosphorus pentasulfide. Phosphorus yet again. We have di, which is going to be 2. We have sulfide, which is sulfur. And we have penta, which is going to be 5. And there you are. That's how you name those things. And then, what kind of bonds do diatomic molecules have? Well, first of all, diatomic looks like this. H2, we have N2, we have F2, Cl2, Br2, I2, O2. And so, each one of those atoms are non-metals. So you put 2 of them together, you have 2 nonmetals. Well, 2 nonmetals, they form a covalent bond. covalent bond. If you have something like KCl, KCl has an ionic bond. See, because that potassium is a metal, and that chlorine is a nonmetal, and that forms an ionic bond. But when you have two nonmetals together, that forms a covalent bond. Well, let's look at the second part of this, shall we? And we're on the ionic side. Two types of elements that ionic compounds are made of. That would be metals for the first part, and then nonmetals for the second part. Okay? About as simple as it gets. 5 properties of ionic bonds. We already did the covalent one. So, ionic compounds. And so, they have a high boiling point and high melting point. They are rigid. They form what's called lattices. They're not flexible. Not flammable. Okay. They do conduct electricity. And they dissolve in water, H2O, and that's called dissociation, or dissociates. Dissociates. That is the term you're going to want to know for tomorrow, dissociates. So an ionic compound are electrons shared or transferred. They are transferred, creating ions. How ionic compounds are named? Well, the first thing, it's like the covalent. The first part of the compound, you write the element name. No prefixes, guys. No prefixes in ionic compounds. No prefixes. Second part to that, this is the anion. You write the element name plus IDE. Okay, and if it's a transition metal, if transition, you are going to use Roman numerals and parentheses. I don't know if I can spell that right. Parentheses, I guess. ES. Okay. All right. Nonmetals. What do they have to do to become a certain type of ion? Nonmetals are going to gain electrons to become negative ions, and metals are going to lose electrons to become positive ions all the time. And here we are at the last part. Potassium bromide. Potassium, now don't get confused. Potassium is not P. That's not the symbol. It's K. And it's going to be a 1 plus charge. And bromine is going to be a 1 minus charge. And since the 1 plus and the 1 minus cancel each other, we're going to write KBr. Okay? Now, this next one, copper. Please remember, and you've got to use your periodic table. Copper is a transition metal. So you're going to use parentheses. And there's a charge for it, so that's the number that's going to go in parentheses. So that's going to be copper, 2, and then the fluorine is going to be fluoride, right? And so if you look at that, guys, I'm going to erase that circle right there. Those two numbers, the 2 and the 1, are going to switch. So you're going to have CuF2, okay? Iron 2 sulfide. So we have iron and we have sulfur. Sulfur is a 2 minus charge, okay? So if sulfur is a 2 minus charge and we have to have a total charge of 0 for the entire compound, then fluorine has to be a 2 plus, okay? So those are the charges. We have iron 2 sulfide. So the 2 is going to go way over here. And that's going to be, well, hold on, I'm wrong. Excuse me. Take that off of there. There we go. These charges, the plus 2 and the minus 2, they cancel each other. So, and then that's Fe, by the way. I put just F. That's not good. Fe. It's the compound is going to be FeS. Okay? FeS. Cobalt 1 iodide. So we're going to have cobalt here, iodine here. Now, The iodine has a charge of 1 minus. That means the cobalt's going to have a 1 plus. So those charges are going to cancel each other. Those numbers are going to cancel each other. COI. All right, magnesium carbonate. Magnesium has a +2 charge. Carbonate, CO3, that's a polyatomic ion, has a 2 minus charge. The 2 plus and the 2 minus will cancel. Then you will write instead MgCO3. Okay. Well, on this one, aluminum with a 3 plus and a hydroxide, which is a polyatomic ion with a 1 minus. The 1 will go to the aluminum, the 3 will go to the hydroxide. The formula will be AlOH, and there's 3 of them, so we put those in parentheses, and there's a 3. So how do we name that? Simple. Al is aluminum, so write the name. And then hydroxide, that's the name of the polyatomic ion. Well, just write hydroxide. That's how you do that with polyatomic ions. Hydroxide. There we go. Okay. We have calcium here, and we have a phosphate. Same process. For calcium, simply write calcium. For phosphate, simply write phosphate. Okay. So these two charges, that one and that one, they were already switched. So to show the charges, we're going to unswitch them. Calcium has a 2 plus charge anyway, it's in group 2. Phosphate has a 3 minus charge. You can look at your polyatomic ion chart, and there it is. Okay. So that is your review for this test tomorrow. Please practice a little bit and study, and we'll see you then. Good luck.